Hello, you are welcome to today's lecture on Spearman's rank correlation coefficient. The Spearman rank correlation coefficient is one of those correlation coefficient that we find very useful in psychology and in other behavioral and social science uh, courses. So we use it to analyze mainly ordinal data or ranked data. So today, um, at the end of this lesson, you should be able to understand what Spearman rank correlation, as denoted by ROS, what called rows, is. Then you should be able to differentiate Spearman rows from Pearson's PMCC. Then you should be able to calculate Spearman rank correlation coefficient following a step-by-step approach. And finally, you should be able to interpret the results in context. Pearson correlation is quite different from Spearman correlation in that Pearson measures the strength of linear relationship between variables, um, in the sense that Pearson will always use interval or ratio data in that are normal in running its analysis. Pearson is best for elliptical scatter patterns, and it's not suitable when relationship is curved or it does not have outliers. While on the other hand, Spearman rank correlation is used when the relationship is monotonic, that is, it's either increasing or decreasing, which means that it is not linear in nature. Uh, rank data is used in Pearson correlation instead of raw values, unlike what we have in Pearson. Then the Spearman rank correlation is less sensitive to outliers. How do we calculate the Spearman rules? Um, they are basically 5 steps to run the Spearman analysis. Number one, you have to rank both sets of data, either using X or Y or A or B or one or two, it doesn't matter. Then step two, you find the differences in the rank denoted by the letter D. Then after finding the differences in the ranks, you have to square the differences, square them, and then number four, you apply the formula, and lastly, you interpret the result. Just these 5 steps are universally consistent when calculating the Spearman rule. Now, this is the formula. When you have no tied ranks, rows is denoted by 1 minus 6 summation d square divided by n bracket n square minus 1, where d is the difference in ranks and n is the number of data pairs, that is the number of data you are pairing. Then I have a worked example here. So this example is a data following showing the annual income per head of a population. The annual income is in US dollar and the infant mortality rate. So the annual income is denoted by X, while the infant mortality is denoted by Y. And the infant mortality is calculated per 1,000 live births for a sample of 11 countries. Let's say the 11 countries are denoted or shown as A, B, C, D, E, F, G, H, I, J, K. These are the 11 countries. And you can see in this table here, we have the annual income per head of the population. Country A has 130, country B 5,950, 5,950, country C 560, country D 2010, country E 1870, country F 170, country G 390, country H 580, country I 820, country J 6620, and country K 3800. From this table here, you see that the country with the highest income per head is country J, followed by country B. And while the lowest income per head is country A, followed by country F. And then you have the infant mortality per thousand. You see, in country A had 1,500, that's 150, which depicts for every 1,000 persons, 150 died, infant died. Then country B, 43, country C, 121, country D, 53, country E, 41, country F, 169, country G, 143, country H, 59, country I, 75, country J, 20, and country K, 39. So you see that there is one unique thing about this data set. The country size, income per head does not actually increase according to the death, in the infant mortality, the ratio of infant deaths in this case. In fact, we are seeming to understand that in countries with lower income per head have higher debt, but it doesn't really apply because country A and country F seem to have low income per head, but country A is lower and has lower infant mortality compared to country F. Now, we want to see whether there is a significant relationship between income per head and infant mortality. Because this data seem not to be very normal. It's not linear, so we will use the Spearman. So one method of calculating Spearman rank is demonstrated below. I'm going to show you the steps, very easy. As we go along, I will encourage you to take your calculator and take your pen and paper and be solving alongside so that you will understand this clearly. You can see I now have to rank. I can decide to rank the numbers, like in this case now, I am ranking the data. In this case, the income per head of the population, which is depicted by with the letter X, and then the infant mortality, which is depicted by we use Y to show indicate it. So I will rank X and rank Y in order of from the lowest to the highest. The lowest I will rank as 1, and the highest I did rank it as 11. If you see here, the lowest is country A and it's ranked as 1, while the highest is country J, which is ranked as 11. So you can see country A is 1, country F is 2, country G is 3, and so on and so forth. Take a closer look at that. You will see that the sequence is consistent for rank. You can decide to use any other thing to rank it, any other letter to rank. What matters is that you follow the sequence of ranking. Then you rank in a similar way to you rank infant mortality from the lowest to the highest. In this case now, country J is the lowest, is ranked as 1. Country K is ranked as 2. Country E is ranked as 3 in terms of infant mortality. And country A is ranked as 10. Finally, country F, the highest in infant mortality, is ranked as 11. So now we will now plot, go the next step, we'll plot this in a table. In a table, another table like this, where we can easily find the difference and square the difference. The first column of that table will be country. A, B, C, D, the 11 of them up to K will be outlined there. And then we have already shown the rank X. We know what it is before now. So you show rank X. This is a rank we have obtained before now. If you look at it, rank X is shown there. And then you see it here too. The same thing too with rank Y. Rank Y, we rank it as we just put these figures as we obtained it. And then the next thing to do is to find the difference. To find the difference, you subtract rank Y from rank X. That means 1 minus 10 will give you minus 9. And then 10 minus 4 will give you 6. 4 minus 8 will give you minus 4. 8 minus 5 will give you 3. 7 minus 3 will give you 10. 2 minus 11 will give you minus 9. Then 3 minus 9 will give you minus 6. Then 5 minus 6 will give you minus 1. 6 minus 7 will give you minus 1. 11 minus 1 will give us 10. Then 9 minus 2 will give us 7. You see, that's the total rank. If you sum this rank together, you are going to get 0. One simple way of doing it, which I have also shown in some classes that I have taught so far, is that you add up all the negative score, you add up all the positive score, you are going to get the same figure, which means that the negative minus or the positive minus the negative will give us 0 at the end of the day. If you don't get 0, it means that there is a problem in your calculation. Then the difference, the square of the difference, you now simply square it, square each difference. Minus 9 square will give you 81. Take note that minus 9 times minus 9 will yield a positive score. So minus 9 square is 81. 6 square will give you 36. Minus 4 square will give you 16. 3 square will give 9. 4 square, 16. Minus 9 square again, 81. Minus 6 square will give us 36. Minus 1 square will always give us 1. And minus 1 square, 1. Minus 10 square will give us 100. And 7 square will give us 49. Then when you add this together, you can do the addition. You will get 429. It is this 429 that will not apply to our formula. Remember, let's go back. You see our formula, summation D square and N. These are the two things we are looking for. So we have got D square. We have to add it to get summation D square. So when you sum it, we have summation D square. Then our total ranks will be, in this case, 11. So you can see it applied in this formula. You can see it applied in this formula. Below here, you see summation D6, summation D square, divided by N brackets, N square minus 1, as shown in our earlier formula. So you now see, you put in the scores. So it will now be 1 minus 6. Since there is no sign between the summation and it will now be multiplication sign that will be there. That is how it is. Then times our summation D square now is 426. Then divided by N, 11 bracket 11 square, which is n square minus 1. So now if you calculate 6 times 426, you will have 2556. There will now be 1 minus 2556. And if you calculate 11 square minus 1, that's what you will do first. 11 square minus 1. Then whatever you get from that, you multiply it by 11 and you will get 1320. Take note again. 11 square minus 1. Just say 11 square. That's 11 times 11. Then subtract 1 from it. The result, you simply multiply it by 11. So when you say 11 square, you are going to get 121 minus 1. You will get 120. Then multiply 120 by 11. You have 1320. So that is the outcome. Then when you sorry, a little audio problem. Okay, we're back. So when you divide 2556 divided by 1320, it will give us 1.93636 and so on and so forth. Which is approximately 1.934. Then subtract 1 from that figure, 1.93636. You will get 1 point minus 1 point minus 0.936 or thereabout. So that's our rows. That's our answer, but it's not our conclusion. Now the next thing is to calculate the degree of freedom. The degree of freedom for a Spearman rank correlation coefficient is calculated by subtracting 2 from the number of data pairs using the formula degree of freedom df equal to n minus 2. In our example here, we have 11 pairs of data points. You would have 9 degree of freedom. If you say 11 minus 2, it's going to give us 9. So why do we have to say n minus 2? The number of observation, this is the total number of data pairs in our data set, is n, which is 11. Subtracting 2, because you have to subtract 2 because it's a linear relationship. In every linear relationship, there are 2 points. There's always an x and always a y. So how to use degree of freedom? Degree of freedom are necessary for comparing your calculated Spearman rank correlation to the critical value in a significance table. It helps us to make a conclusion of our results. When reporting the Spearman correlation, the degree of freedom is also often used or included in the report as in P, degree of freedom, to show us the degree of freedom, and then the arrow value, that in our case here, the Spearman value. So P is the P value, as in the case, what we obtained from the degree of freedom. Then this is our table. I have already shared this table to you in class. So if you check the table, level of significance, the Spearman table, critical value for Spearman rank, other correlation, you can check your WhatsApp, or if you have printed it, you check the table, you subtract alpha 0.05. You see, look there, you see level of signal one tail, the one at the top. Then you see alpha equal to 0.1. Then you see alpha equal to 0.5. Then the next one is alpha equal to 0.025, and so on and so forth. The one that we use in this class, which I have always told you, is alpha equal to 0.05. Now you marry that first alpha 0.05, which underneath it is alpha equal to 0.1. That's not what you're interested in. You are looking at alpha 0.05, one thing. You marry it with 9. Our rows value, our table rows value is 0.564. So our critical value is 0.536. So based on that, we can conclude that since our calculated rows is minus 0.936, this is greater than our critical value, our table value, rows crit, which is 0.536. We conclude that there is a significant negative relationship between income and infant mortality. So summarily, this result represents a strong negative rank correlation between income and infant mortality. That is, infant mortality tend to fall or reduce as income per head of the population increases. What this is simply saying is that countries where individuals have income, higher income, tend to have lower infant mortality. Please, it will be important to state that the negative value in our rows here should not determine whether it is greater or less than our critical value. It is just indicating whether the relationship is positive or negative. Or if we have a positive value, it means that as rank X is increasing, rank Y is also increasing. But if we have a negative value, it means that as rank X increases, rank Y also will, in the other hand, reduce. So that is the essence of that negative value. It should not be used to compare. And that's just the uh, idea behind them, Spearman rank, and even Pearson too. So it's also important to note, in conclusion, too, that a plus one result in Spearman or even Pearson means that there is a perfect relationship or a perfect agreement. Then a zero score means that there is no relationship, while a minus one result means that there is complete disagreement or perfect negative relationship. But however, in real nature, it's almost impossible to obtain these values. If you look at our value, the value we obtain from our result, which is uh, minus 0.936, this is almost a perfect relationship. Ordinarily, we don't need to look at the table to conclude that it's going to be significant because it is quite close to 1. So you can see that there's almost a perfect negative relationship. And what this simply means is that if I'm not saying that this is a real data or this is a real study, but assuming we do a real study and we come out with this, as psychologists, we always advise that uh, countries should make sure that income per head of the population is increased, as this will result to reduce infant mortality. So thank you for listening. Please, I have this take-home assignment. You are free to solve it. The table below lists 7 schools and provides data about the percentage of pupils who have free school meals and their GCE results. So the free school meals is the X, is what we rank, what we are calculating as X. And then the GCE result is what we are calculating as Y. So I want you to calculate the rank correlation coefficient and explain what this means in the context of this question. So, what does it mean? Does free school meals, does it result to uh, increase the GC result? So you can see the schools. There are 1, 2, 3, 4, 5, 6, 7 schools here. So the free school meals, you can see the percentage of free school meals. The percentage here is here. So you can see that the highest free school meal is at Eagle High School. So while the lowest free school meal is at Green Gauge. So you can see the pupils pupils gaining 5 or more GCEs, the number of pupils that gain 5 or more credits in, let's say, WAEC grades. You can see them in that Green Eagle High 37. You can see even with their high preschool meal, they still got 37. While Copperdale, which is just in the middle, just somewhere in the middle, not too high, not too low, they have 44. And then you see schools like Butterscotch with almost low free school meal having 64. Now, this data needs us to confirm whether free school meals significantly uh, improves pupils gaining 5 or more credits in GC grades. So take that as an assignment and send your feedback. Thank you for listening and have a wonderful weekend. And then remember to subscribe to my channel. Remember to subscribe if you wish so that you can continue to get um, sample questions and explanations of statistical uh, tests like this. Have a blessed day.